So next topic is the internal energy. So according to the definition, the internal energy of a system is the sum of all kinetic and potential energies of all components of the system. We use capital E to represent it. So internal energy means total energy of a system, and total energy means all the type of kinetic and potential energies. When you can add all together, that equals to internal energy, and internal energy is represented by capital E. And generally we do not know the capital E, only how it changes. So delta E means change in internal energy. And this graph, this picture here, it shows that here's internal energy. Usually when represent on the graph or on the paper, so if the system have the internal energy which is shown by this straight line, and as the process or state change from one state to another state, and if the system is losing the energy, loss of energy from the system, represented by the red arrow pointing downward from the state, initial state to final state. So if the system is losing the energy, we have to write like this one. So initial energy and then final energy, which is less than initial energy. So this shows that loss of the energy means we are losing the energy, and final energy of the system will be less than the initial energy. So energy lost by surrounding initial energy of the system decreases, means delta E will be negative. I will show you how this delta E is negative in the next slide. But in case if the system gain energy by the system, gain of energy by the system represented by the blue arrow pointing upward from initial state to final state. So if any system gain energy, we usually represent that it is gaining, means, and arrow goes up. So if the system is moving like this, it means this is the initial state, this is the final state, it means we are losing the energy. And if the system is showing this kind of graph, it means we are gaining the energy from the system. And energy gain from the surrounding internal energy of a system increases, means delta is positive. So what is the meaning of positive and negative, we will see next slide. So by definition, the change in internal energy delta is E is the final energy of the system minus the initial energy of the system. So what is the meaning of delta E? Delta E means E final minus E initial. So here one example is given, that initial, when hydrogen and oxygen gas react together, in this line is showing the initial state, and they loses the energy to form water. So loses the energy means their final energy will be less than the initial energy. So delta E will be negative. So E initial, E final will be less than E initial. So if this negative sign is bigger, it means result will be delta E will become negative. So this is the way we said that E initial greater than E final, therefore energy is released from the system to the surrounding during reaction, and delta E is less than 0. It means it will be negative. Let's see another scenario. So here is the same thing. If delta E is more than 0, so this is different. More than 0 means E final is greater than E initial. So basically we are talking about this kind of system where E final will be greater than the E initial. So delta E will be E final minus E initial, and if E final is greater than E initial, so delta E will be positive. And then the system will absorb energy from the surrounding, and that type of system is called endothermic. Endo means inside, thermic means temperature or heat or energy. It is taking inside, so basically gaining. We are talking about delta E is positive means we are talking about this type of graph which is going up. Next is so here is one more example about the endothermic reaction. So when heat is absorbed by the system from the surrounding, the process is called endothermic. For an example, this picture shows the beaker have ammonium thiocyanate and barium sulfate, these two together, and when we measure the temperature, it is room temperature, which is 23 degrees Celsius. When they react together, ammonium cyanate and barium hydroxide, so they form barium thiocyanate and ammonia gas releases, and water molecule also form. So heat flows from surrounding into system, temperature of the beaker and surrounding air drop. So you can see this temperature is here 23 degrees Celsius and here is minus 11 degrees Celsius. So when barium hydroxide and ammonium sulfate react together, what they do, they heat flows from surrounding into system, so they absorb heat, and so basically we are talking about this kind of system. So this will be E initial, E initial, and then E final. Like this one, endothermic reaction, E final will be greater than E initial. So this system is absorbing energy from the surrounding. That is why temperature of the reaction goes below from the initial, and this reaction is called endothermic. Endothermic means energy is taking in. Let's see another example is when delta E is less than 0 means delta E final E internal energy of the final will be less than the internal energy of the initial. So the system release energy to the surrounding and also called exothermic. So when a system have the initial energy like this one, and then it loses the energy from the system and it releases the energy into the surrounding, then the final energy will be less. You can see it showing basically downward, so loss of energy is going on. So it is going from top to bottom, means it is losing the energy. So E final will be less than E initial. So delta E will be less than 0, means it will be minus. So this type of system is called exothermic. So let's see one example for this one. So when the heat is released by the system into the surrounding, a process called exothermic. So basically we are talking about this kind of system where E initial is higher than the E final, and delta E will be E final, which is less than E initial. So delta E will become positive. So here one example is given, like a potassium. This piece is potassium solid. When added into water, this beaker containing water, it form potassium hydroxide and releases hydrogen gas, and this reaction is very vigorous. It releases a lot of energy, so that is why it's called exothermic. Exo means out, so out means energy is coming out from the system into the surrounding. So heat flows violently from system into surrounding. Temperature of the water and surrounding air increases. So this is the way you can distinguish the exothermic and endothermic reactions. Let's summarize the exothermic and endothermic. Here is one example. So endothermic means heat flows into the system from surrounding. So the graph will be like this one: E initial and E final. So for an example, water solid means ice. When ice melt, basically it need energy from the surrounding to become liquid. Another example is, another word is exothermic, means exo means out. So heat flow out of the system into the surrounding, means water in the gaseous form means water vapor or hot water. When cool at room temperature, it loses the energy. So here we are talking about this kind of graph. So E initial will be higher than the E final. So this is the example of endothermic, and this is the example of exothermic.